Hello, my name is Alex Glickman, and today I'll be talking about the computer and internet usage in the United States over the last 12 years. This database had two flat tables. The first table shows the number of users, which was an integer, and the percent of computers and percent of internet use at home, which are both floats, by year, which is an integer. The second table has the number of users that live in homes with internet, have internet at home, and have access to internet somewhere else, which are all integers, along with the percentages, which are floats, of each of these columns. These are all grouped together by state, which are strings. Here is a visual of the columns by each table. While the type says text, it's translated over when I went to Python of the ones that I stated before. It was either integers, floats, or strings. While this data is good to see the trends of the last 12 years by state, it does have some limitations. This data is only derivative, so that means that the raw data is not shown. There's no big data picture that you could see who's using data where. It's all the final answer. This doesn't prove that this data is accurate. Also, the state data is only 1 year, which doesn't say which year it is, and the year data is only for the United States as a whole, instead of having state data by year. Finally, it is hard to show if the data was entered correctly because of the variety of sizes. There's a lot of outliers that could be true, but also could be typos. But the data was able to answer these questions. The first question was, how does the percent of households with internet compare to the size of the whole state? To answer that question, I made a query that had three columns: state, total people, and internet percentage of households. This all came from the internet usage by state table. I had it so state does not equal United States because there was a row that had all the data collection in it. And I ordered it by total people so we could see how the scatter was in a more organized manner. We can see by this graph that there is no correlation, and it seems like any size could have any internet usage percentage. The second question considered, how has internet usage compared throughout the years, and what is the mean for those years? The SQL query for this question had two columns, year and internet use at home percent. This came from the households with computers table, and I ordered it by internet use at home percent. As you can see by this visualization, after the year 1997, the percent of households with internet increased by year. Before 1993, however, there was no internet users. So with a mean around 2000, you could see how the internet has increased so much in the last 12 years. Using the amount of rows and the total percentage of internet usage, we could see that 42.7% is the mean for the last 12 years. That's around 2000, so you can see the increase from there. Third question will answer, what states have the least amount of internet usage? This SQL query had two columns, state and access, from internet usage by state. I ordered it by access ascending so we can get from the lowest ratings to the best, and also limited it to 5 so we can see the bottom 5. As you can see, West Virginia, Louisiana, Mississippi, Alabama, and New Mexico all have the lowest internet access, which they had under 70% of. Three queries and visualizations could have some social impacts. It could affect marketers, government, citizens, and service providers. Marketers of computers or people who use the internet to advertise should pay attention to where people are on the internet the most, and also the least. The government can regulate the more people, maybe the more tax on it, or vice versa. The large internet users should stay in denser areas to get better service. So for example, West Virginia has low internet access, so people should stay away from there if they need to be on the internet. Service providers should focus on denser user areas because more people are there and there's more customers. There can be conflicts with this data also. the less dense areas may not be looked at by the service providers and not get any more internet access. And with regulations or service providers, the more dense areas may be upcharged.